The triangle that we are interested in the most, especially for our purposes of doing some of these problems with cubic unit cells, are right triangles. So here's a right triangle. What's the distinguishing feature of a right triangle? Somebody tell me. Okay, Pythagorean theorem has something to do with it. What else? What about this angle stands out to you? Or what about this? I just gave it away. What about this triangle stands out to you? It's got a 90-degree angle. It's got a right angle. Okay, right there, 90-degree angle. Now, some parts of the triangle that we should be familiar with. This longest side of the triangle, does anybody remember what this is called? Yeah, this is the hypotenuse. Hypotenuse. All right, what about each of these guys? Each of these other pieces. What are these pieces called? Remember that? Remember the legs of the triangle? All right, we've got two legs. Oop, that's just a leg. And one hypotenuse. Okay? So we've got a right triangle here. Now we've got a special kind of triangle that we are going to see, especially when we start working with some of our body-centered cubic cells that are going to become important. If each of these legs is equal to one another, which is not necessarily going to happen, but let's say that leg equals leg. All right, we could even like name this, right? Like we can name this ABC. That can be the name of our triangle. All right, so if BC equals, call this AB, what can you tell me about the angles here? What kinds of angles are those if these legs are the same length? They're 45 degrees. I don't know why my, sorry, I'll try to turn this back down. Seriously? Come on. I'm trying to get rid of these shadows. There we go. Okay. All right, great. So then each of these angles, so angle BCA and angle BAC are going to equal 45 degrees. Remember how we name angles, right? This would be angle BCA, BAC. Okay? And naming conventions. All right, now I heard somebody else mention something that was distinctive for right triangles. It was some kind of theorem. What theorem was it? The Pythagorean Theorem. All right, Pythagorean Theorem. Theorem. It's the reason why I teach chemistry and not spelling. Okay, Pythagorean Theorem. Does anybody remember what the Pythagorean Theorem is? A squared plus B squared equals C squared. A squared plus B squared equals C squared. What this is saying is that if we call one leg A and the other leg B and the hypotenuse C, the square of the hypotenuse is equal to the sum of the squares of the legs. Okay. So if you know the length of the two legs, you should be able to find the length of the hypotenuse. If you know one leg and the hypotenuse, you should be able to find the other leg. This is going to be handy when we start looking in just a little bit. Scooch that down just a little bit. When we start looking at some actual problems, the Pythagorean theorem is going to be very useful. The other kind of principles, trigonometric principles that are going to be very useful are our basic trig functions. All right, now I'm going to redraw. See if I can scooch this down a little bit. All right, I'm going to redraw a triangle here. Another triangle. Another right triangle. Okay. All right, so again, name this the same convention, ABC, triangle ABC. So I've got my hypotenuse here, hypotenuse. We can use our trig functions to define the length of the sides in terms of the size of the angles. Okay, so we're going to use lengths of sides now to give us information about the angles. So let's look at angle BCA. All right, we're interested in this angle right here, angle BCA. Okay, I want to know information about this angle based on the length of the sides. Now, if you remember your trigonometric ratios, we've got some shorthands, right, to help us remember what the trig functions actually stand for. Does anybody remember like the most common abbreviation? SOHCAHTOA, right? SOHCAHTOA. I don't really like SOHCAHTOA because when I was a little kid, my father taught me trigonometry by using this method. Oscar and Oswald have had algebra. All right, you can use either way. Either way makes sense to you. You can remember SOHCAHTOA, you can remember Oscar and Oswald have had algebra, whichever way that you like. All right, first trig function is going to come from the SO and also from this first part of Oscar and Oswald have had algebra. This ratio is called sine. It's abbreviated SIN, okay, so just cut off the E. The sine is equal to the opposite over the hypotenuse. Now that's one reason why I like Oscar and Oswald have had algebra, is because it sets you up really nicely to see like which one's on top and which one's on bottom, but to each their own, okay? All right, now you might be wondering, where is the opposite? Here we've got a person right here, standing right where this angle is. All right, here's my hypotenuse. Where is my opposite? Is my opposite AB or is my opposite BC? What is it? AB, right? Think about it like, it's a person looking at a wall, right? It's the wall directly opposite to you. So if I was going to set this up, opposite over hypotenuse, it would be the length of AB over AC. All right, we've got another trig function. It comes from COV, SOHCAHTOA, or A over H, cosine. Okay, we can abbreviate that COS, and this is adjacent over hypotenuse. So my adjacent side, if this is my opposite side right here, again, it depends on the angle we're looking at. If we're looking at this angle right here, this is the opposite. This is my adjacent side right here. So if I'm looking for cosine, I find BC over AC. That ratio gives me the cosine. Last basic trig ratio that we have is TOA. That's tangent, abbreviated TAN, and this is just opposite over adjacent. Okay, so I would put this length over this length. That ratio gives me the tangent of angle BCA. Put that right angle sign right there. Now we have other trig functions, right? We have, cosecant, and we have secant, and we have cotangent, right? Which are just the reciprocals of all of these trig functions. You are not going to need those for the basic trigonometry that we are doing in this class for Chem 102. If you can do the Pythagorean Theorem, and if you can do sine, cosine, and tangent, you're going to be set up really well to be able to do these problems.